Okay.
Hello, everyone. Welcome to the FE Review Workshop number 1. We're going to be going through some mathematics and statistics today. Anybody that joins the session midway will be here and be able to ask questions as they will. Otherwise, we're just going to get started and go through a couple things. We had some technical difficulties this first time, so we might be a little shorter than normal, but we're going to do our best anyway. I have my secretary, Anthony Cameron, here, who's going to be coming along for the ride.
Hello.
All right, let's get started. So we have, if we're going to start off with some mathematics here, I'm going to try my best to draw with a mouse for what it's worth. I will hopefully be getting a drawing tablet soon, so that'll be a lot better. But for the time being, we're going to be dealing with the sensitivity of a mouse. So when you think about mathematics, what normally comes to mind is actually quite a vast topic. You got analytical geometry, you got calculus, differential equations, you got linear algebra. There's a lot of topics in the math section. So we're going to be going over a little bit of all those. And if somebody has a conceptual question, I'll do my best to answer it to my knowledge. And another small disclaimer, this workshop is not in any way, shape, or form 100% comprehensive. We are not going through over everything, and we're not going through every topic that could appear on the FE exam. If we did, well, might as well just make a whole new business doing that, right? But there's already businesses that do that. So this is kind of just for students, members, non-members alike, to kind of just review some stuff if they want to. Okay, without further ado, let's get into this problem. Okay, we have an area. We want to find the approximate area bound by two curves, which is y equals 8 minus x squared and y equals -2 plus x squared. Just from inspection, if we were to draw maybe a straight line, that would be nice. What do these two look like? Again, when you're solving this on the FE, you kind of want to do it as fast as possible. So I'm not saying you should graph everything that you see. It might be an easier way. We'll get to that in a moment. But just from an inspection, we can say, okay, these are going to be two parabolas, right? A parabola is going to be at -8, and a parabola is going to be at -2.
-8?
Oh, my bad. +8. Thank you, Mr. Cameron. And it looks like they're both going to be, so this one's going to be, let's say 8's about here, and let's say -2 is about here. One is going to be, this one on the 8 is a minus, so it's going to be something like this. And the one over here is going to be something like this. So it wants the area that's bound by these two curves. Pretty simple, right? One thing that we do need is to know is these points where they intersect. That's not too hard to find either. And Anthony, can you tell me what method would be used to find the area between these two curves?
Well, we would have to equate the two y equations. Figure out where they're equal.
Correct. And then to get the area under the curves?
And then we will integrate both equations and take the difference of those two equations.
Correct. Wonderful. So let's see what that looks like. So let's first equate these. 8 minus x squared is equal to -2 plus x squared. And we could find that x squared is equal to 10. X is going to be equal to the square root of 5. So now we know that this is going to be the square root of 5 plus minus, mind you. So plus square root of 5 here and minus square root of 5 here. All right, cool. We have now what we're going to use that for is our integration bounds. We're going to be integrating from this section here to this section here. So if we take an integral from -radical 5 to radical 5, we can take, doesn't matter which one goes first, 8 minus x squared. Wow. Minus negative 2 plus x squared dx. So we can integrate both of these. What do we get? What do we get? If you know the one of the fundamental laws of calculus is you can apply your integration. If you have a sum or a difference of two integrations, you can split up the integration sign and do one at a time. So we can do this one first, and then this one after. All right, how do I extend my page?
That I'm not 100% sure.
That's a good thing to know how to do, huh?
Yeah, to get a bigger page.
There's a select button. Space. Whiteboard. Oh, these are the whiteboard controls. Don't tell me I really got to erase that. That's not fun.
Erase everything and.
Oh, and well, let's see what this is going to become. So this first one we're going to get what? 8x minus x cubed. What is it? 1/3 x cubed.
I believe so. Yeah, if I remember correctly.
Yeah. And evaluated at negative radical 5 to radical 5. And then minus 2x plus 1 over 3 x cubed. Again, evaluated at radical 5, negative radical 5, a and b. And what do we result with?
Let me see.
Well, if you had a calculator, it would make it a little easier.
Yeah.
I also wish I could extend my page, so I think I can. Oh my.
Oh, you can.
All right, that's one way to do it. This radical 5 got left behind. Okay.
Hey, Nick, I'm gonna have to hop off here. I got a dorm meeting at 3.
That's fine. I'll be here doing a couple more of these.
Okay. Good luck.
Mm-hmm. So 8 times radical 5 negative radical 5. Wait, yeah, negative radical 5. And minus 1/3 negative radical 5 cubed. Just do some small calculations. Times 8 minus 0.33 times negative 5/3. This comes out to be about negative 14.2. And we do it again with the positive one. It actually turns out to be a much different number. 2.6. And then if we do the other one, which I'm certain everyone here can plug in numbers, the end result will be around 30 or 28.9. 29.8. So if you were to look at the answer choices, which in this case are 22, 27, 30, and 45, you would choose answer choice C to represent. All right. Well, cool. With that done, let's move on to another one. Let's do more math. Gradient concept, let's stay out of concepts for now. Let's do some other integral. Too many integrals. Oh, my whiteboard is gone. Where did it go? Okay, how about some parametric equations? If you remember parametric equations, they are from around Calculus 3 era. So we have text, I'll type this out. X equals 2 times t squared minus t, and y equals t cubed minus 2t plus 1. These two equations, right? We want to find dy dx. So this might look a little more complicated than it actually is. What we're really going to be doing is defining this little differential right here. So since these equations are functions with respect to a time t, to get dy dx, we can do as follows. We can take dx dt and dy dt, and we can get some values from these. So if you want, you can pause and try and work out what this is on your own. If not, that's cool too. But what we'll get is 4t minus 4t for the dx. And that is done using the power rule for derivatives. If you're curious, you can look that up if you want. We're not going to covering that here. For dy, we'll have 3t squared. Oh my, that's wasn't right. 3t squared minus 2. Okay. Okay, so now we have a dx dt and a dy dt. So if we want a dx dy, what can we do? Or sorry, dy dx, we can do dy over dx is equal to, just take dy over dt, and that's going to be over dx over dt. So in that regard, the dt's will then cancel out, and we're just left with dy over dt. Is going to be 3t squared minus 2 divided by 4t minus 1. And with that, this is our final answer. If you're curious, some of the answer choices were 3t squared. All right, different color. 3t squared, 3t squared over 2, 4t minus 1, and And the last one, which is answer choice D, was this here. So with that, you're able to find the answer pretty easily. Also, this is another one that you might be able to solve by inspection, since you know that both of these equations, their first derivative with respect to time t is not going to be, one of them isn't going to be 1, or it's not going to give you like a constant. So you know that you have to have a t in the numerator and the denominator if you were to have a dy dx. So that will instantly eliminate actually all of these answers and tell you, hey, the only one that's right is the one that has a t in the numerator and denominator, which is represented by answer choice D here. So I hope that was helpful. We can move on to another one too. Let's see. Differential equations sounds cool. Let's do that. That number 6. Oh, right. Let's see how many of you remember how to do differential equations. Okay, we have y prime plus 5y equal to 0. Okay, well, can you guys tell me what type of differential equation this is? Yeah, okay, so it's yes, first order, and it is definitely separable. So we can write this this y prime as a dy dx. Yeah, dy dx dt, whatever you want it to be, doesn't really matter. The problem uses x though, so we'll do dy dx plus 5y equals 0. It is also homogeneous since there is no function or constant on the right side of the equation. With this, we want to get all the y's together and all the x's separate. So we're going to have dy equals negative 5y, move the 5y over, multiply by dx, then divide by y. So dy over y equals negative 5 dx. And if you remember your integration, you're going to integrate both sides. Before I finish, let me write down some of the answer choices. We have a y equals 5x plus c. B, we have y equals ce to the negative 5x. C is y equals ce to the 5x. And then D at, which is saying either A or B. Okay, so just looking at these answers, D seems strange. I don't know how a differential equation could have 2 different solutions. Maybe some can, but in this particular one, I don't think that's possible. So A looks like we have A is a solution without any exponential term. Okay, fair enough. Though those of you who've taken a differential equation class, what does that tell you? Yeah, as x tends to infinity, this will, go to infinity as well, which in mechanical engineering at least would be a symbol of an unstable system. But looking at C, that also is the case. So maybe we can't rule that out like that. That's fine, let's solve it and see what we get. So we're gonna get, what is the integral of a dy over y, which is basically the integral of 1 over y dy. It's going to be the natural log of y. And we're gonna equal negative 5 times x. All right? So now what do? We got to get this y out of the natural log. So we're going to raise everything to the e power, e to the ln of y equals e to the negative 5x. right? Anybody is choosing here? All right, so this here is E and ln is going to cancel, so we're going to have y equals, and we're also going to have a plus c here, e to the negative 5x plus c, but this c here can actually just be rewritten as a c constant in front of the exponential due to its arbitrary nature. So we actually come up with the solution being the stable system, which makes sense right here. Stable mechanical system as our answer. Awesome, awesome. I'm going to do another differential equation problem. This one's a little more difficult. Maybe not that one. Yeah, this one. Yeah. All right. It's number 8. All right, we have y double prime minus 4y prime plus 25 over 4y equals 10 cosine of 8x. All right, we have a second order non-homogeneous differential equation here. So now you're like, oh no, what am I going to do, right? It's going to be nuts. So we do know it is a second order. I should probably let me get the answer choices out too. I was kind of involved. We have 2c1 x plus c2 x minus c3x. B c1 e to the 2x plus c2 e to the 1.5x. C c1 e to the 2x times cosine of 1.5x plus c2, same thing, only sine and c2. Okay, and the c1 e to the x times tangent of x plus c2 e to the x. All right. Oh, this is cotangent. Cotangent. Okay, so those are our answer choices, and we have this differential equation. Okay, well, first things first, how will we start to solve this? Whenever you see a non-homogeneous differential equation, you first start off with the general solution, and then if you need to, you go to the particular. I think it's actually important that I write down the actual problem at hand here. So you guys might catch something here. It is asking what is the complementary solution to the following equation. Complementary solution, if you guys don't know what that means, that's okay for now. For now, let's look at this. The complementary solution is referencing the general solution. It is not asking you for the particular. So you can already look at some of your answer choices and see which ones would instantly not be considered. If it's only asking for, it's a second order differential equation, it's only asking for the general solution, which means you're only going to have two terms, C1 and a C2, without the particular solution. That means A is immediately not a candidate. It also means you don't have to go to the length calculation to find a particular solution. And that's why you shouldn't waste time. If you read the problem wrong, you may be wasting more time than you think you are. So let's go and find the characteristic equation. We have r squared minus 4r plus 25 over 4 is equal to 0. Is our characteristic equation. We can find the roots to this, probably through the quadratic formula. Four plus or minus square root of 16 minus 25 times 1, yeah, over 2. So we're going to get 4 plus the square root of negative 9 over 2, and 4 minus the square root of negative 9 over 2. Over 2. Not too bad looking, actually. 4 plus 3i over 2, and 4 minus 3i over 2. So this is, now that we know, we can look at this just right now. We know it's going to be we have imaginary roots. So this is a complex solution. This actually, just knowing this, we can find the solution to this problem, because only one of these has a proper form. Well, actually, I guess two of them technically have a form of a complex solution for a differential equation. It's not B. B doesn't have any sine or cosine. The complex solutions for differential equations contain sine and cosine as a oscillate, so that's because the solution oscillates on the imaginary and real axes. As you can see, I personally have never seen an answer that has tangent and cotangent in it involving a differential equation. Now that may exist, but if you're low on time, I think a good guess would probably be to guess C as your answer, since it has a sine and a cosine and a sine in the answer. But let's say you don't know that, and let's see what we can gather elsewhere then. So when you're solving one of these complex solution differential equations, there's going to be two values you're going to need to get from this information we currently have, and that's your alpha and beta. Alpha is going to come, or we need an A and a B, and then we can get an alpha and a beta, because the general form that this is going to look like, let me move some stuff around. Oh, it's not erasing all those. General form of this, y equals e to the alpha x times c1 cosine beta x plus c2 sine beta x. That's the general form. So we need beta and alpha values. How do we get those? Those are going to come actually from this right here. Change color. This and this. This is going to simplify to 2 plus or minus 3/2 I, 1.5 I. Two plus or minus 1.5 I. Beta is going to be the imaginary part, and alpha is going to be the real part. that is denoted as well. So with that, we have alpha and beta over here. We can plug those in for these values, and well, what do you know? 1.5 is beta, and alpha is 2. So that confirms that C is our answer. But you could have also determined, before you even calculated your roots for this, you could have already seen by this. You could have just taken b squared minus 4ac and see if that was imaginary. And if it was, you could immediately eliminate 2 or 3 of the answer choices, and you could have gone through that problem without even having to do much calculation. These are kind of some of the tricks that you can use in regards to this. Nice, okay. What else do we got? Okay, equation of a circle. Oh, calculus. Let's do this one. Some calculus scheme here. So you all know I have solved some of these problems myself, but not all of them. So some of these we're going to be looking at for the first time. Pretty cool. I do tend to want to solve the ones that I present to you all, so I don't spend too much time figuring it out myself, so we can get through stuff and questions and whatnot. This one. Nice. Oh, that's a lot of text. Okay. Wish there was an easier way to get this over there. All right, so can I make that? Text. Okay. If a crop of peaches is picked now, 1,000 lugs of peaches will be obtained, which can be sold at $1 each lug. For each week that picking is delayed, the crop will increase by 60 lugs, but the price will reduce by 0.25. 0.025 dollars per lug. So additionally, 10 will spoil for each week of delay. So what do we do in order to maximize our revenue? How many weeks? So we're looking for a time t. How many weeks should you wait? Okay, nice. This is one of those word problems that you can look at and be like, oh man, I don't know where to start. So first of all, we can look at what are we being asked? We're being asked for a time t. Let's not use yellow. Asked for a time t that will maximize our revenue. Okay. And let's see what we are given. We are also given a value of, looks like a first value of 1,000, and a price per, another price per, how much it increases by per week, and how much it reduces by per week. So let's get some general terms here. We're probably going to have to write a relation between everything in order to get the answer. So net price, let's do input. We're looking for T. big goal, T. I'm just going to draw a star around it, but that's a little too complicated. Just draw lots of shapes around it. So T is our goal. Let us now see what we have. $1 per lug, but every week it'll reduce by 0.25. So the net price per week going to be $1 minus 0.025. Do you agree with that? What does that give us? .975. Okay, I can take that. Hopefully you can see this. Okay. So the thing about this, hold on. We have to add, because this reduces each week. So we have to put a T next to our 0.25. So it will reduce with in respect to time T. And that's going to be our cost, price, cost. What we'll call it F. Or maybe we'll just call it C, that's better. Okay, now what else do we have? We have 1,000 lugs. We start off with 1,000. There's no time dependence on that. And we'll increase by 60, but reduce by 10. So we're going to have a plus 50 times T. This is going to be our L, our lug amount, over a course of time T. Nice. So now we want to maximize our revenue, and how many weeks do we need for that? I'm going to call our revenue function R. So we actually, what we're just going to do is kind of multiply these two together, L times C. So we'll get the 1,000 plus 50T times 1 minus 0.025T. We're going to get a quadratic cube. It's okay, that makes sense. So now let's multiply this out. We're going to get 1,000 minus 25T plus 50T minus 1.25T squared, which will reduce to, I'll just erase this to reduce it, to save some space. $1,000 plus 25x or T minus 1.25T squared. All right, so now we have R. What are we looking for? Maximize revenue. Who remembers how to maximize a function? We got to do some tests, right? Since it's maximizing, we got to find our global or local minimum or maximum. In this case, it's a maximum. So what we'll do is we'll take a nice red derivative here. dr dt. What are we going to get here? See, funny thing is this 1,000 does not really factor in at all in this derivative terms. Kind of funny, huh? So we're going to have 1.25 times 2, 2.5. 2.5T plus 25. So equals 0. what is our answer going to be now? May have messed up on the unit somewhere. Yeah, this is negative. Okay. Yeah, so that will come out positive. So if we do the math here, 25, negative 25 divided by 2.5, also negative, is going to be a positive. What's 10, right? 10 weeks. And if we look at our answer choices, I don't have them written down, but we have 2 weeks, 5 weeks, 7 weeks, and D is 10 weeks. So with that, we choose D as our answer here. Very nice, very nice. Yeah, see, problems like this are not too bad if you can realize that you have to basically just maximize a function, but you have to come up with the function yourself using, relations between price and whatever it is that thing is relating to, which would be the lugs in this case of peaches. Nice, okay. What do we go to next? Statistics probability. Statistics probability. Number 2. All right. Okay, so let's say a couple things about statistics before we actually get into some of the problems in case you've forgotten. There are some different methods you can use in your calculator and some equations that you might want to know. Also, remember everything could also be referenced in the FE handbook. I'll send one of those to the Discord after I am done with this, so you guys can reference that. It's actually very useful. It's really useful just for normal homework problems too, because who knows when you may need one of those equations for any of your courses. But for this one, we're going to be looking at some statistics. So if you are familiar with the permutation versus combination, if your calculator if they have a math function, you can actually you can incorporate and use some of those in these to prevent having to do extra work. Okay. So let's first look at what is a permutation. Permutation P of n comma r is going to be n factorial over n minus r factorial. Now what is n and r? N is our set amount, so how many items are in our set. Sorry, that looks like an H. I'm just gonna and then we have R, which is going to be our items that we will be using. So how many of those items in that set are we using for our test? So that's what P is. There's also one that is called C, which is a combination. It's a permutation. Combination of n comma r is going to be equal to the permutation of n comma r divided by r factorial minus n factorial divided by r factorial times n minus r all factorial. Things mean the same here. It's just a different measuring device or system. I don't quite remember the difference other than you would use a combination when you have a subset of elements taken from a set where the order is not significant. For a permutation, it is conscious of the order. Subset of elements where the order does matter. so let's say you have like a keypad, and if the order does matter when you put in the numbers in the keypad, that would be a permutation calculation. But if it did not matter, you just need to get the right numbers. That's a combination instead of a permutation. So now with that being said, let's see some of the problems we're going to see are going to include some of these. So what if we had, let's say, it was asking what is the probability of, event A and event B happening at the same time. Okay. And then happening at the same time, and then imagine if it asked what's the probability of event A and event B happening at different, or sorry, one or the other happening. Event A, event B. So you can think of an and or as either a addition or multiplication. Also consider joint probability. So let's first look at the probability of A or B happening instead of both of the same. Right, or with P of A and B probability of A and B happening if, no, they could be dependent on each other or not. This is for all cases. We're going to have, it's going to be the probability of A times probability of B. This line here is going to be, we're going to say it, probability of B assuming A has happened already. So this is if we wanted, this is going to be the same. You could also replace the A with B, and B assuming A has already, or sorry, A assuming B has already happened is the same thing. I'll write it out. If A and B are independent and are not dependent on each other, let's say you had a birthdays, you want to find out what's the probability of two people having the same birthday. That would be something that are dependent on each other, because if one person has a birthday on April 2nd, your pool then for the other person's birthday not being on the same day, instead of 365 out of 365, you'd be 364 out of 364. So that 364 out of 365, sorry if I said that wrong. Probability of A having the same birthday, 365 out of 365. It's 1, right? Because if our group is only a group of 2 people, the first one, there is no one else to compare them to. So basically, probability of them having a birthday on a specific day is 100%. But now, probability of B, person number 2, assuming that person A's birthday is on April 2nd, that would not be 365 over 365. That would be 364 over 365, right? So the probability of 2 people having the same birthday would be 364 over 365 times, or multiplied by this one. And there might be another factor as well that I am forgetting. Let me check. Birthdays. Yeah, it's gonna. Yeah, sorry. This is in. This is the joint probability for or. So this is the probability that of them not having the same birthday, 365 over 365 times this probability. Probability of them not having the same birthday is actually very high. It's about 99% chance of them having it on different days. So that is how this particular one will work. There is another one. Let me erase this on the top. That is an or is an and, so both happening at the same time. We're going to have P of A plus P of B, or P of A plus B. It's going to be probability of A plus the probability of B. But we're going to subtract the probability of A or B happening at the same time. And B, sorry. Okay, P or B, A and B happening together, A and B, one or the other happening. All right. So with this, I'm actually going to jump into the first problem. Where did it go? Matter of fact, I didn't close it. No, it's this one. So we have a bag that contains about 100 balls, each numbered 1 to 100. One ball is drawn from the bag. We want to know the probability that the number will be odd or greater than 80. Okay. Let me type out the problem. Bag contains balls. One number 1 to 100. One ball is drawn from the bag. Probability that the number will be odd or greater than. Actually, guys, I think I made a mistake. This one with the plus sign is the or. This one here is the and. This one is the or. So the explanation I did before to switch the and and the or. All right. So answers we have 0.1, 0.5, 0.6, and 0.7. So our answer set. Okay. Probability that the number is odd or greater than 80. So we have two events, the number being odd and the number being greater than 80. So we're going to use the or relationship right here. So what's the P of A? What is PA? A is going to be that the number will be odd. So what's the probability of a number being odd in a bag of 100 balls? It should be 50, right? 50 out of 100. Right, exactly. Okay, what's P of B? Probability that it's greater than 80. 20 out of 100, right? Exactly. Now, what is the probability of them both happening, if it being odd and greater than 80? Let's remember from the previous discussion. P of A and B is P of A times P of B, assuming A has happened. So for the scrunchiness. So if we assume P of A is going to be still 50 over 100, what's P of B assuming A has happened already? Are these two things independent of each other? Yeah, they are independent of each other. Whether you pick an oddball versus a ball greater than 80, they do not depend on each other. So this will end up just being 50 over 100, 0.5 times 0.2, which I think is 0.1, 0.2, 0.1, yeah. So we're going to have 0.5 plus 0.5 plus 0.2 minus 0.1, which is going to equal 0.6 as our probability. So that puts answer C as the correct choice. Not too bad, right? Okay. Okay. That is it for that problem. Hopefully that was clear. About out of time here, so let's see. Do we have anybody else here? Nope. Let's look at one more statistics problem. Standard deviation, it's not so bad. That's just the birthday one. I already explained that. This has got to be this one. Okay, let's do this one. All right. Measurements of the water content of the soil from a borrow site are normally attributed with a mean of 14.2% and a standard deviation of 2.3%. What is the probability that a sample taken from a site will have a water content above 16% or below 12%? That's a long one. Let's widen that. All right, so we're talking about normal distributions. This is another thing that I can explain if you do not quite remember. So when you have a normal distribution, you have a normal distribution is almost still what they call a bell curve. I can get this right. Okay, where you have about 99 to 98% of your data within 3 standard deviations of the mean, which the mean would probably be around here. So every standard deviation you go away from your mean, you're going to get, you know, so this is 1 SD, 2 SD, 3 SD. Call it sigma. Right. What you can do, there is also a chart in the FE handbook that you can use to see the table of z-scores, which you will most definitely need for this problem to represent the normal distribution and how we can get the data from that. So let's go ahead and try and solve this problem then. And I'll explain any necessary stuff. Okay, that's why we're doing this. Any necessary stuff in the meantime. So we need to get the standard normal values for our points of interest. So we have a 14.2%, standard deviation of 2.3%. Yeah, normally distributed with a mean of that and standard deviation. What's probability a sample taken from the site will have water content above 16 or below 12. So 16 and 12 are our interest points. So if we take this 16%, or let's see, what's the equation for the z-score? Because the z of 16%. It's going to be x, which is our point of interest, minus the mean divided by the standard deviation. So we have that. What are we going to get? We're going to get 16% minus 14.2 divided by 2.3. Wow. This is going to give us about 0.78. And if we do the same thing for 12%, it's going to be 12 minus 14.2 divided by 2.3. It's going to be negative 96.96. So if we go and look at the table, let me get that. If you review, what is it called? Where do I have it? Handbook. Okay, let me share this on here. Don't know if it will keep my whiteboard. I hope it does. Share this. So hopefully you guys can see this now. Hopefully we can search for standard normal. And that's thermodynamics. Oh, it's only searching for standard. Normal distribution. We're going to loop around through unit normal distribution. Here we are. So you can see here's the bell curve and the different sections. So what was it we were looking at? We were looking at a 12 and a 16%. We wanted to know if it was between those two. Seems a little bit like this one right here, this 2rx. The before and after. We could also maybe use one of these, like this one. So how do you know which one you should use? Well, since we were dealing with two separate, let's see. I think actually both will work. It just depends on, you have to make sure you get the right one on the 12 or the 16. Yeah. Okay, so Let's go back to the whiteboard. So actually, if we remember, point 16, that one gave us what number? It gave us like a 0.78, right? 0.78, so maybe we can round to 0.8. So we look at 0.8. If we look at Rx, we have 0.2119. Okay, so we can say that the z-score for that is 0.2119. And what was the 12? 12 was about 1. It was like 0.98 or something. So we look at 1, we look at the same thing, 0.158. 7. All right, let's go back to our whiteboard. Yeah, or it was negative. Negative 1, okay. In being negative, what that would change, I actually think that it doesn't really matter whether it's positive or negative. It would just determine what spectrum that you're looking at. But since in this case, we're looking at least one, maybe one standard deviation out, we can use Rx for most of these kinds of problems. So we have, what is the term? Rx of 16% gave us 0.2119, whereas Rx of 12% gave us 0.1587. All right, now you may be thinking, what do we do with these? Well, we want the probability that X is below 12% and above 16? Above 16, below 12. Okay, so we're gonna do X less than 12 or X greater than 16, the opposite. And that we would add 0.2119 and 0.1587 to give us about 0.3706. Okay, so that's actually about a 37 probability of 3706, 37%. Because then the reason why it was the opposite, we want the probability, because it says above 16 or below 12, so it's the probability that this data will fall outside of that set. So we put the probability of what it would be in the formula. We put X less than 12 greater than 16 to get the what is the probability for it landing out or outside of that set, which should just be 37.37. Okay, that's about all we have for today. Thank you all for tuning in if you did, and to Mr. Cameron, who was here in the beginning, and if you're anybody who watches this in the future, thank you. Hopefully you come to more of our Taupita by FE workshops, and we hope to see you again some other time. Thanks. Take care. Let us know if you have any questions in the comments. Join our Discord server for more information. Take care.